Mad Maths 2011, Paper 2, Question 12. I'm going to draw a diagram to show the forces. So we have the car and the trailer, and we'll have to have a tension in the toe. You have 3,450 pulling it forward, and the resistance to the car is 0.8 newtons per kilogram. So that's 0.8 times 1,050, and that gives us 840. And there'll be a resistance to motion on the trailer. So part 1 asked us to find the resistance to motion on the car, and we can read that off the diagram as 840. In part 2, to work out the total resistance, if we consider the particles as 1 with a mass of 1800 with 3,450 and a total resistance to motion of x. So we have that 3,450 minus x has to equal mass times acceleration. So 3,450 minus x has to equal 2,160. So the total resistance has to be 1,290. If the total resistance is 1,290 and the resistance in the car is 840, then the resistance in the trailer will be 1,290 minus 840, which gives us 450 newtons. We're asked to find the tension in the tow bar. So if I just consider the trailer, tension's pulling it forward, 450 resisting motion. So tension minus 450 is the resultant force, has to equal mass times acceleration. 750 times 1.2 gives us 900, so T minus 450 equals 900. The tension is 1,350 newtons. We're now considering only the trailer. So the trailer has a resistance to motion we've just worked out of 450, and its mass is 750. So if we look at this diagram, the trailer's moving in this direction, so the resultant force is minus 450, and that has to equal mass times acceleration. So the acceleration is going to be minus 45 over 75, which gives us minus 0.6. The coupling broke when they're moving at speed 12. We want to find out when it stops. The acceleration is minus 0.6, and we're interested in finding the time. So V equals U plus AT. 0 has to equal 12 minus 0.6 t, so t will equal 12 divided by 0.6, which is 20 seconds. Distance travelled will be u plus v all over 2 times t, and that gives us 120 metres.